This question asks us to provide a mechanism that forms product B, even though it looks like product A might be the logical choice for the product of this reaction. The first thing that's going to happen is the oxygen is going to get protonated. We'll use a lone pair on oxygen to get protonated by H2SO4. That will form the protonated alcohol intermediate. The protonated alcohol intermediate is now a good leaving group, so we can break the carbon-oxygen bond and the alcohol can leave. That will form a carbocation intermediate. In a regular elimination, we would eliminate the beta hydrogen to form the alkene in this step. However, this is a secondary carbocation next to a tertiary carbon. So we can do a hydride shift where we break the carbon-hydrogen bond and shift that hydrogen over to carbon to form a tertiary carbocation. When we do, that carbocation becomes an sp2 hybridized carbon, so we lose the stereochemical information, so we should not draw any wedges or dashes on a carbocation, an sp2 hybridized carbon. Now that we have the tertiary carbocation, now we can do the elimination reaction. The hydrogen on the wedge can be eliminated using water. Water will form an oxygen-hydrogen bond, break the carbon-hydrogen bond, use those electrons to form the alkene, and that will form product B as the major product of this reaction rather than product A.